Hey guys, this is a video about ways to make your programs reusable and scalable using three or maybe four methods called inheritance, polymorphism, encapsulation, and the fourth might be interfaces. Now, I'm going to use Unity for um, this explanation, but it's not tied to Unity. It's used in different, like in ASP.NET or whatever code, or maybe C++ or whatever. But we're going to use it for a Unity. Now, Martin Fowler once said, I said this one before, that any fool can write a program that a computer can understand, and good programmers can write code that humans can understand. Now, and this is basically the idea about object-oriented programming. Now, there are many ways that lead to Rome, and that also counts for programming. I mean, you don't necessarily need to use any of these methods, or heck, you don't even need to remember the name of polymorphism. It's just a way to you can write your code and make it reusable, scalable, and essentially make your life a little bit more easy as a programmer. Now, you don't have to follow these, like I said, you don't have to follow these guidelines, but they sure do help you a lot when you are making a program, and whatever program it is, and even, I mean, especially when your program grows, um, or when you program it, you finish it, and after a few months you come back and you want to expand it a little bit. Well, then um, it's very handy to use some sort of way to keep your code clean and reusable. Now, with that said, let's start first um, with these concepts. Now, polymorphism cannot exist without inheritance from a base class, and encapsulation is something which happens inside a base class. So they are pretty much tied to each other. Now, most of the time when you search the web for this part of object-oriented programming, you always find the same animal, dog, cat, make sound example, and we're going to use something else, maybe more focused towards making a game. So we are going to do. We're not going to make a racing game, but we're going to use an example to make a vehicle or a car and even multiple cars. And I will show all the different um, usage of all the four stuff I just said, like interfaces, encapsulation, polymorphism, and inheritance. And I'm also going to show you a way. I think we're going to do it something like, because I didn't prepare anything, we're just going to go with it while we're at it. Um, so we're just going to do some programming and then do it one way, uh, maybe the way you would do it right now, and then we're going to switch it over to how you could do it using one of these object-oriented pillars, as Microsoft calls them. Okay, with that said, let's create a few scripts. Maybe first start with one C# script. Let's call this, imagine you want to create a game, a racing game. So you just start with a vehicle class. Now, again, we're not making a complete game. Let's remove the mono behavior from it now. So we just got an empty class. If you're using, I should have used Visual Studio for this video, but I'm gonna use monodevelop because my other laptop is not here. Well, don't mind. I said that doesn't really matter. Okay, so we got a vehicle. Now, what a vehicle needs, and this is also something about programming, you need to um, make every class like responsible for himself and not for something else. Example, if I would have public, let's call this throttle, or maybe gas, public void give gas, throttle up. I'm sorry, throttle up. Now, this is something which belongs to the engine. So you could, it's in the vehicle, but any implementation of this throttle up should actually go to a part for the vehicle, or for the engine. So I would have an engine class right here. I should have it to do my throttle up and work it out. But that's not what I'm trying to say. I'm sorry. Okay, so you want to like isolate everything from every other class and make them loosely coupled, as they call it. Loosely coupled means you can use it in some other class as well. I mean, if you got an engine, you want to swap your engine without making a complete new vehicle class. And if you see where I'm going. Okay, so I would make a vehicle. I would have a few methods. Call this throttle up, public void brake, stuff we need in our car. We would have wheels, so maybe we would have 4 wheels. Let's say we have a vehicle of 4 wheels, so we say public wheel. We don't have this class, but then we say front left, public wheel, front right. Well, you get where I'm going. Now, if I would make this entirely, and I got this set up, and I'm going to say this is a class, I'm going to give it a public string name. This equals to my BMW or something. I don't have a BMW, but imagine I have. Now, so this way I could make a vehicle which is of a type BMW. Now, if my manager or boss or whatever, or myself decides to make a new vehicle like an Audi, whatever you call it, Audi, then I would make a copy of this vehicle class and make it string name Audi, or I would instantiate the vehicle. Let me give you an example. So this is the public class vehicle. Now let's make a public class BMW. Now, in our constructor of our BMW, we would go public BMW. Then we say a private vehicle. I hope you understand what I'm trying to say. If it's too difficult to understand, please let me know. Vehicle equals to a new vehicle. And then we say vehicle name equals to BMW. Now, if I wanted a new vehicle, I would go copy this over to a new class and create my Honda. And I would say Honda. Like so. Honda. So now I got 2 vehicles, and the only thing they both have my they have a throttle up, they have a brake. I can use everything. Use everything from our instantiated vehicle class. Now, this is actually okay to use. I mean, this is simply a normal way of having a class, and then you instantiate a new class, and then you assign properties. You get the methods for it and stuff. So that's a way you can do. But let's first start with the first thing, and this is an interface. Now, I don't often use interfaces because I think interfaces are very handy, especially if you work with more programmers. So because it's basically a contract for classes. I mean, if you implement an interface, because you implement an interface, you inherit from a base class. So when we implement an interface, it will tell you what kind of methods you need to use. So let's make an example. If we make our public vehicle class an interface, like interface, public interface, and let's name this like so, capital I, and then your name. Now, then we would not have any implementations in our interface. It just tells us what kind of methods and properties you have in your uh, classes, which implement the interface. So this would be let me see. Let's remove these for now. I probably don't need to have the public because it doesn't. An interface doesn't tell you if the property is public or private here. Now, so if I got an interface iVehicle and my BMW implements the interface iVehicle, it will require me to implement these methods. Now, if you would in Visual Studio, you will get the red curly thingies below the iVehicle, which will tell you to implement the interface. Now, with monodevelop, you can right-click it, then you say refactor. No, sorry. Here it is. Implementer classes. I'm not really sure. No. I thought it would tell me that I needed to implement the interface. Maybe I'm missing out on something. No, I'm sorry. I don't actually see it. Now, but I know I would need to implement the throttle up and the brake method in our BMW class. Now let's see. Oh, I made a typo, I think. Oh yeah, cannot contain fields or constants. Now I'm assigning here a value to the name, which isn't supposed to be. Come on. This should be, I'm sorry, gets up, I guess. Like I said, I don't use interfaces a lot. There we go. Now, what happens here, what happened here, maybe to explain first, this is a property, and it's required a getter and a setter, otherwise it would be a constant. So it got a property name and two methods, throttle up and brake. Now the BMW implements the interface. Now if I look here in Visual Studio, you will see it in the bottom of your screen. Now it says it does not implement throttle up, brake, and a getter and setter for the interface members. Now I think I should have the. There we go. Now if I check refactor, it will tell me, if I right click here, it will tell me to implement the interface, or I can interface explicit. Now if I implement the interface, just right here, now what it does, it will simply add all the methods and all the properties from the interface to my class which implements the vehicle. So it's a contract between the iVehicle, it's a contract between my class which implements the interface, and it will tell me, okay man, you can be a BMW or a vehicle of whatever type, but you need to have these classes. Okay, now the error disappears because although I'm not even using it, it just requires me to have these methods. So this is an interface. Now another thing you can use is inheritance. So you can inherit. Now we are inheriting an interface, but you can also implement. I'm sorry, we are implementing an interface. You have to get the naming right. Implementing an interface, but you can also inherit from a base class. Now, one more important thing is you can only inherit from one base class, but you can implement multiple interfaces. So let's give this an example. We got the iVehicle. Let's have an engine as well for the interface, which has whatever power. And we have a base class. You can make, I'm just typing everything in this class just to make a little bit quicker. Now we can say a public class, what would be handy to use, vehicle class, maybe just call this a vehicle base. And my vehicle base class got a method, public void sound horn, because I want every car to be able to sound a horn without making any methods for it specifically. Now I would be able to implement the iVehicle and also the iEngine by adding a comma here, and then it will I can implement this interface as well. Let's put it right here, and let's maybe make it a little bit more readable by implementing the interfaces myself. So just making sure that we have all the methods. So I have the public sound horn, which comes from iEngine, and we have our public void throttle up and our public void brake from iVehicle. Okay, now I also need this name thing, but I'm going to remove it because just extra typing. So now I got all the three implementations for both interfaces implemented, so it will compile correctly. If I got power set. I'm sorry. This is a property power. I'm sorry. This doesn't work. This isn't, of course, iEngine. You probably saw this already. This is going to be a member. So let's make this a public string power get set. So this is basically from iEngine. Now it should compile. There we go. So without knowing anything about making a car, if I implement these interfaces, it will tell me exactly what you need to do in your program or in your game, which kind of methods you need to have for the vehicle to function. Make sense? I bet. Okay, now the vehicle base, our base class, which you inherit from, is also behind these double things. I don't know how you call them in English. But important to know, you have to put this one at first. So first you inherit from your base class, and everything after the comma are interfaces. So you can only inherit one base class and implement more interfaces. Now, with this vehicle base, we have access to our sound horn method from our vehicle base. So we can say public, honk, honk here. Maybe we could try this out in the editor. Honk. Now in our we're not going to do it from a honk. We're not going to do it from the game. I think it just doesn't make sense. Okay, so then we got our public whatever method, do my honk honk, which will be sound horn. Now, the IntelliSense gives me the sound horn because I inherit from the vehicle base. All right. Now, again, let's create a new car here for our Honda. Now, you see, this is very easy to create a new car without even knowing what's going on. The problem is right now, because what we are doing right now are interfaces and inheritance. But we always have to program our throttle up, our braking and stuff. And this is where you can use polymorphism for. Um, so, am I forgetting something here? Well, we could do one more thing here, which goes for polymorphism, because we don't have to change anything else for polymorphism. Because I could make a method, I don't need to use sound horn, but it's also possible to make a method, mark the method virtual. Now, if I mark it virtual, I can override our sound horn method. So I don't need to, I can do it like this, no problem. But I could also type the override keyword here. And then it would tell me from vehicle base, I was pointing with my finger, which you don't see, but from vehicle base, tells me here, I can override the sound horn method. And what this does, it will, when the sound horn method is called, it will come here, execute anything between these parentheses, and then it will say base sound horn. Base is essentially this method. If I don't want to use this method at all, I can simply not do it, but still have a sound horn implement. So I have here sound horn, which is my default horn. And now I have my sound horn, but I say no, it's not going to be a more exotic horn, which I can play right here from the same class. Now, if I have my Honda, I override sound horn, and I just play whatever the sound horn from my base class gives me. So I could make the sound horn the way I want, so make my own implementation of my sound horn, or I could use the implementation from the base class. Now I could also do something here before the base, or maybe after. I can do whatever I want, and both will get executed. Okay, so this is a very quick example about polymorphism. Now, one more thing I said which you can do is encapsulation. Now, encapsulation is another term which you probably don't need to remember, but maybe you have been using it already. Is like we are protecting our stuff from our classes. So, example, public string, maybe int, set whatever, tire pressure. Set tire pressure. And by default, my tire pressure equals 10. Now, when my constructor for my BMW comes along, I have access to my vehicle base, so I can say set tire pressure. Maybe it's not a very good name. Let's call this tire pressure. Tire pressure equals 2. So I can change my properties from my base class. One more thing which we use at our company and maybe we're not the only one to do this, but I really prefer to use it. If you type this, which like it said here below, this keyword refers to the current instance of the class. So this equals to BMW and everything, the base class and stuff behind it. So if I type this and I enter a period, I can see everything that belongs to this instance of a class. If I hit just type here, I can use it, but it gives me a lot of more properties from any um, public methods from my using statements. So I prefer to use, if it's a property from this class, if you just type this and you select then your tire pressure or whatever, then it's always understandable for yourself and maybe other people to understand where this property comes from. You know, I can look at it and see where it's from, but this tells me immediately what's going on, which brings me to something else. If you make a method, like in our BMW, we're gonna say public, we want to open the door. We don't make a method calling do this. I mean, opens the door. I mean, do this doesn't tell me anything about the method that's going on. Always make your method names self-explanatory. I mean, it let your method tell what's going on. Also, don't make your methods too long, a minimum amount of lines, and split it up into multiple lines. So if you have like a very difficult calculation, just make a method, private method or whatever, and then you say here do int my result equals to a new method called do difficult calculation. I'm making a typo, doesn't really matter. Just make methods out of it to keep it usable. Okay, so you don't say do this to open a door, you say open door. Might seem obvious, but just do it like this. We'll always keep it clear. Now, back to encapsulation. So I can change the tire pressure. Now, what if you don't want your any derived class? I mean, this is the BMW, which inherits the vehicle base, is a derived class from vehicle base. So this derived class, if you don't want the derived class to change any parameters, because you are maybe making a public void pump wheels, which likes going will add pressure to tire pressure, whatever, tire pressure. So I don't want to maybe change the stuff that's going on with the tire pressure here. So what we're gonna do, we simply gonna mark this tire pressure private. So then I can use the tire pressure in new tire pressure equals to tire pressure, whatever. But then I cannot really change. I cannot change the tire pressure here. So I can only say pump wheels. Come on, pump wheels. And whatever's going on with my tire pressure, it doesn't really matter to the BMW here. So if you want to be able to read, one more thing, what we do is all our private methods or private properties are will always start with a lowercase and then a Pascal casing type way, and every public starts with a capital one. So now it's private. I'm going to change it here to private as well. Okay. Now, what if you want to be able to not read the tire pressure, but you want to read the tire pressure, but not change the tire pressure? Then you could change it to something like this. And these are two ways. I could go for a method here, public int get tire pressure, which will return the tire pressure. This is one way to protect my tire pressure but still be able to int tire pressure equals to get this get tire pressure. Okay, now this is one way to do it. Another way you can do it is to make a property public for a getter and private for a setter. So then we say a public int tire pressure. Then we say private, public get private set. There we go. Give me a sec. That was the baby. Okay, so now let's mark this one public again. So with a capital. Let's remove this. This for an example. Let's remove this as well. Now, if we try to var tire, maybe int tire equals to tire, this one tire pressure. Now, tire pressure. So this will get the property tire pressure. But if I want to assign it, well, I hope you're guessing it, equals to null. This should not work, and it will not work, I think, if we look here, if we compile it. There we go. Now it says public get private set. Oh, maybe like this. Okay, so it needs to be get private set because the accessor is public here, tire pressure, and we have a private set. So now it doesn't tell me here, it will tell you in Visual Studio that this is not possible. If we look here at the console, it tells me that the property, or indexer, and this time property, tire pressure cannot be used in this context because the set accessor is inaccessible. It tells me exactly what I want, right? What the problem is. Now, one more thing you can do, you could also make this internal. You can make a method public, private, or internal. There we go. So now with the internal set, I can use it here, but I cannot change it from outside anything of this class. So this is basically about the internal. So if we switch this back, this should work again. Okay, so this is an example of let's just quick recap: interfaces, inheritance, polymorphism, and encapsulation. I really hope you have learned something from this, and if you want more information about it, or maybe give a better or new example, just let me know in the comments, and I would really like you to help me out to reach this video to other people by hitting the like button, and hopefully more people just like you will be able to follow this video. Alright, that's it for now. A little bit longer than I expected. Yeah, see you around.